And here we are with yet another factoring technique for polynomials. This one's called factor by grouping. So kind of in the name tells you a little bit what you're going to do. I think the best way to go about doing the factor by grouping usually is just look at some examples and you kind of get a sense of the process and the idea, and you're noticing the form of how the polynomial initially looks, and then a way to proceed, in this case, the factor by grouping. So first example here, okay, we want to factor, and again, we're factoring all these completely. So here we have x cubed minus 3x squared plus 2x minus 6. So notice this one here, that's a little different. Right? In the past, we may have only had, if I just covered this up quickly, I had something like that, right? This is a quadratic. We have ways to factor that, okay? Notice what's different here is we have this other term. We have now 4 terms, right? How something looks does tell you a way to maybe try and proceed. So in this case, the way this looks, we're going to proceed with the factor by grouping. So here's the idea. We're going to look to factor this, and if we look and say, what's in common with all 4 terms here? Well, there's nothing in common with all 4 terms, so I can't take a monomial out. That's not going to work. Okay, so, all right, there's no monomial. Now what? Well, this thing collectively doesn't factor, but maybe I can find a common factor somehow by partitioning this off, right? In this case, grouping the terms. So what I'm going to do is I'm going to group the first 2 terms. So here I'm going to put x cubed minus 3x squared in parentheses. And now here plus, and then group 2x minus 6. Okay. Now there's nothing to factor out of all 4 of these, but now when I group right there, those 2 terms, this I can factor something out. I can factor out a what? A common monomial of x squared. So there's that common monomial that I factor out. Now, what's left? I'll use some color here. Let's go with blue. What's left is, when I factor out x squared, I'm left with x minus 3. Okay. Now, if I go over to the other binomial, what can I factor out of this? I could factor out a 2. And then what's left when I factor out the 2? I'm left with x minus 3. Okay. Now, hopefully what we notice is here I have this term, right? A term is separated by addition and subtraction. In this case, I have this term, which has the factors x squared and x minus 3. I have this term here, which has the factors of 2 and x minus 3. So what I now can do is factor out from both of these in blue a common factor of, in this case, x minus 3. Okay, so now I'm factor out the x minus 3. So let's do that. So here I have a common factor. I have factors of x squared and x minus 3. Here I have factors of 2 and x minus 3. So what's in common between these two is an x minus 3. So I factor out the x minus 3. And when I do that, what's left? What's left is, well, when I factor out the x minus 3 from here, what's left is x squared. When I factor out of x minus 3 from here, what's left is plus 2. Okay, so in this case, you're factoring out not a monomial, you're actually factoring out a binomial. Okay, but it should be pretty obvious when you see it. Visually, I can see the common factors. There it is, x minus 3 and x minus 3. Okay, so then I'm going to write out the common factor x minus 3, and then what's left is, you can really think about this. Once I identify this common factor, I can think that once I write this down, there it is, I can get rid of that, and look what's left, x squared plus 2. Okay, and just like we said before, anytime we factor, we want to say, can anything factor? I have x minus 3 times x squared plus 2. Does this factor anymore? No. What about this? I see a square, but this is a sum, right? This isn't any type of factoring we could do. So in this case, this would be done. Okay, so there's the first factor by grouping we have. I'm going to do a couple here. All right, second example, factor by grouping. Here's where we got to be a little more careful. Let's go with 2x cubed plus 8x squared minus 3x minus 12. We still always want to look for that monomial to begin with. Is there a common monomial factor between these terms? Okay, is there common? If we look, we say, nope, 2, 8, 3, 12, no, there's nothing, x cubed, x squared, x, no x, nothing common. So now this looks like if it factors, okay, if it factors, we might want to try factor by grouping. So we're going to group maybe the first two terms, 2x cubed plus 8x squared. Now, here's where some of you are going to go wrong, so pay attention to this. Minus, okay, minus, but then this is what happens. We group the next two terms, okay, and without thinking and just doing and going kind of go through motions, we don't recognize that there's a problem here. But the problem is, well, over here, let's say I got rid of these parentheses. Is there anything I have to do to get rid of these parentheses? There's the one in front, so I could just get rid of them, and I'm back to where I started. Here, if I started with this and I moved backwards up here, what happens here is I'd have to distribute a -1. Well, when I distribute this -1, I get -3x, but then I get +12. And that's not what I originally had, which means I did something wrong. Okay, and what you effectively did is when you put a parenthesis here, you separated that negative from that 3. So essentially what you did is you divided out a -1. You factored out a -1, which means I then have to also factor out a -1 from here. Okay, which would make that then +12. Okay, so now if I distribute the -1 times the 3 and the -1 times +12, I get back up here. Okay, so be careful. If you have a minus here and you're separating the minus from the 3 or whatever the number is, you got to make sure you change the sign of this term as well. Okay, here the -3 became a +3 when you separate it with that parenthesis, but this one you got to make sure you change it. Now we go and we say, all right, well, what's in common with these two terms? Common monomial is 2x squared. So I factor out the 2x squared. What's left? X plus 4. And then I look here and say, what can I factor out here? What's my greatest common factor here? 3 times x plus 4. And as factor by grouping works, it's going to be pretty visual that you see I have here factors of 2x squared and x plus 4. Here, factors of 3 and x plus 4. So I see I have a common factor of x plus 4. So write down the common factor of x plus 4. Then I can think about, all right, now they're gone. What's left? 2x squared minus 3. And now, does x plus 4 factor anymore? No. Is this a difference of squares or anything like that? Well, I see difference, I see squares, but 2 and 3 aren't perfect squares. So there's no more factoring to do. So what does this factor into? All right, this factors into, all right, and is equivalent to right there. And I could always check my work. Factoring, you know, the one thing that's easy is checking your answer. If I distribute, right, what's x times 2x squared? If I multiply these back to back together, right, check. If you check your work, x times 2x squared, 2x cubed. X times -3 minus 3x. 4 times 2x squared plus 8x squared. 4 times -3 minus 12. And notice that all these terms, right, are the same as what's up here. So I factored correctly, right? So the check should be pretty easy. Just multiply back together. And let's go with one more factor by grouping here. Okay, so this one we're going to make 2x to the 4th. All right, 2x to the 4th plus 2x cubed minus 18x squared minus 72x. Okay, so I'm doing this one to get you to think that what? We want to look for a monomial to start. All right, look for a monomial and say, what's in common with 2x to the 4th, 2x cubed, 18x squared, and 72x? What's in common there? There's clearly a common factor of 2, 2, 18, 72, 2. X to the 4th, x cubed, x squared, and 1x, so 2x. So that's what I factor out first. And then what's left is x cubed plus x squared minus 9x minus 36. So now, once I factor this monomial out, I can kind of forget about this and just keep bringing it along for as long as I need to, right? That's going to just keep coming down. depending how many steps it takes me to get to the end, I'm going to keep bringing it along. So this becomes my new problem, working with this, which you look at that and go, oh, that looks like a factor by grouping. Okay. So that's a factor by grouping. So I'm going to maybe group what? X cubed plus x squared. Okay. Now here, the 9x and the 36, if I separate there, I separated the negative from the 9x. So that means I got to change that to a positive 36. Okay. And now we look here. Again, keep in mind, I'm even for now going to cover up all the 2x there. Okay. Just going to cover that up. I don't even want to think about that right now. Now I try to factor this one. Say, all right, well, what does this become? This becomes x squared times x plus 1, right? Careful, it doesn't become a 0. You're dividing, not subtracting out. You're dividing out. I could factor out here a 9 times x plus 1. And it's pretty obvious that it worked because I see what? I see the common factor of x plus 1. So now I have x plus 1, common factor. There, I factor out the x plus 1. And what's left is x squared minus 9. Okay. And then, yeah, I still have the 2x here, right? So now 2x times all that stuff, okay? So that's what I'm going to have right in front here. I have 2x times that, right? So there's my 3 terms multiplied, okay? And now, like I said, after every factorization, we want to ask ourselves, does 2x factor anymore? No. Does x plus 1 factor anymore? No. How about x squared minus 9? That's a yes. This is a difference of 2 perfect squares. X squared, 9 is 3 squared, difference minus. So now I'm going to have 2x times x plus 1 times x plus 3 times x minus 3. Okay, so that factors into that. Now, every one of these factors can't be factored anymore. That's now done. Okay, so you see there's some more, it's more involved with some of these. But you got your monomial, you got to pay attention to sign. Okay, you have the difference of squares. All right, every stage of the game, every little factorization, you want to check to see if any factor can be factored more. Okay, so that's factor by grouping. So make sure you take notes on this, look it over. If something doesn't make sense, make note of it so you can ask. Okay, let me know if you have any questions on any of the factor by grouping or anything discussed in this video here.